Okay, now we're going to talk about the rules for finding derivatives of rational functions. So here we have the command, take the derivative of the function 1 over x squared. Remember, a rational function is when you have a variable in the denominator to a certain exponent. So let's go ahead. The one thing I recommend you to do, just like in radicals, rewrite first, and then it's a form of the power rule. So take the derivative of 1 over x squared can be rewritten as x to the negative second. So using the negative rule, the negative exponents of the power rule, so this says this is the derivative. The derivative is, so this negative 2 comes down in front, and then negative 2 subtract 1 is negative 3, and then x to a negative exponent will be 1 over x cubed, but there's this negative 2 in front. So we end up with negative sign in front, 2 over x cubed. Okay, so here's something to notice. When there are no coefficients here, look what just happened. This started off as positive, it's now negative. This was the exponent originally. That is now the constant in the numerator, and this is 1 degree more than what started off being in the denominator. So let's try another one. Let's just do the simple one, 1 over x. All right, so you're going to rewrite that. Did I not? Yep, as x to the negative 1. Then we're going to take the derivative. So dy dx is equal, that negative 1 will come down in front, and then we'll subtract 1 up there. So negative 1 x to the negative second dy dx is equal to negative 1 over x squared. And let's come back here and look at this. So that rule, whatever power was here, it's in the numerator, and then it started off being positive, it's now negative, and the new denominator is 1 degree higher. Let's see if that holds. This started off being positive, it's now negative. This degree, that invisible 1, is what's in the numerator, and this degree, x squared, is 1 degree more than that. Let's try another one. So there's a pattern. If you understand patterns, you can kind of self-check. So now we have, this is different. We now have a 5 in the numerator. But we have a 3. Normally, if the rule would have followed, if this would have started off, we would have ended up with 3 over x to the 4th, because if we're following the pattern. But now we've thrown a wrench into it. There is a coefficient or a constant first. So we're going to rewrite this negative sign. So negative 5 x to the negative cube. This is going to come down in front, and then we're going to subtract 1. So we have f of x is equal, well, negative 3 times negative 5 is positive 15, and then that will be x to the negative 4th. So our final will be x cubed is equal to positive 15 over x to the 4th. So this is what's changed. If there is a number in the numerator other than 1, it'll be this exponent times that coefficient. That's what ends up being in the numerator. And then this started off being negative. This is positive, and this is now x to the 4th. All right, so be watching those patterns. It'll make your life easier in calculus.